Hello everyone and welcome to our channel, mootechie. A special welcome to all the dairy technologists and students joining us. Today we are beginning a new and very practical unit. This is Unit 4 and we will be exploring the machinery that puts our dairy products into their final containers, packaging machines. We are now moving on to the topic of packaging machines. These are the machines used to transfer food into the package for distribution and sale. Packaging involves a series of operations. It starts with package preparation, followed by product preparation. Then comes the filling of the products into the packages. After that, the packages are closed or sealed. Finally, they are prepared for storage and transport. There are many types of packaging materials used in the dairy industry. These include metal and glass, such as cans, tubes, and barrels. Film materials are used to make tubes, pouches, and thermoformed packages. Paper is used for cartons and cardboard. And various plastics are used, like polyethylene, polyvinylidene chloride, polypropylene, and polyesters. Packaging can be classified based on its form and use. There are wholesale packs like tanks and churns, which are often multiple-use containers with a spigot system. Then there are retail or trade packs for consumers. These include single-use items like glass bottles, plastic pouches, cartons, and plastic cups. A major part of packaging is the filling equipment used to get the product into the container. There are several important aspects to consider for any filling operation. It must be done under hygienic or sanitary conditions. The filling step must be well coordinated with other packaging steps. The equipment should have a high capacity. It should operate with no waste of product. Precision in filling is crucial, and flexibility to handle different products is a valuable feature. The choice of filling equipment is influenced by several factors. These include the specific product that has to be filled, the conditions under which filling takes place, the required capacity, the type of packaging material being used, and the desired packaging appeal for the consumer. The flowability of the food product is a key consideration. The product can be a liquid, a solid, or a mixture, such as a liquid with solids, a gas with a liquid, or a gas with solids. For liquid products like milk, there are two main methods of filling: cold filling and hot filling. In hot filling, the product is pasteurized, and cooling is done only after the container is sealed. Dosing is an essential part of the filling process. It determines the exact quantity of a product that has to be filled into a certain container. There are several different dosing methods. These include volumetric filling, level filling, weight filling, time-controlled filling, and counting filling. Let's look at each method. First, volumetric filling. This is the most commonly available system and can handle both low and high viscosity foods. It offers reasonable filling accuracy and a high speed of operation. It often uses a cup of constant volume to measure the product. In volumetric filling, the filler transfers the product to a container until a predetermined volume is reached. The volume can be controlled either by measuring the flow rate of the product or by using containers of known volume, where the product is pre-filled before being dumped into the final package. High-capacity machines often have more than one volumetric filling head operating at the same time. The second method is level filling. This is often used for filling liquids into transparent bottles. The product flows until it reaches a certain height or level in the container. Filling can stop when a beam of light sent through the bottle to a photocell on the other side is interrupted by the rising liquid. Another type is maximum filling, where the container is filled to its absolute top, and any overflowing excess material is collected and recycled. This diagram illustrates level filling with a photocell. A light source shines through the bottle, and a photocell detects the light. When the liquid rises and interrupts the beam, the filler stops. It also shows a line for collecting product excess. The third method is weight filling. Here, the weight of the product is checked continuously. This can be done before filling in a pre-weighing system, where the weight is checked as the product is carried on belts. Alternatively, filling and weighing can be done simultaneously. This often involves a balance system. In continuous weighing during conveying, the product is carried in a cup. When the weight in the cup reaches a preset value, the food is automatically emptied into the container. Modern systems are fully integrated with computers for precision. Another system involves continuous weighing during the filling process itself. The bottles sit on load cells, which are connected to a microprocessor. This system continuously monitors the weight and controls the filling valve to achieve the exact target weight. The fourth method is time-controlled filling. This is used for filling small amounts when the product properties, the container, and the filling speed remain constant. However, since these variables can't remain absolutely constant, the accuracy of the final product weight is not very high with this method. The fifth method is counting filling. This is used for packaging individual pieces of food, like fresh fruits and vegetables, or processed items like creams, chocolates, or sweet balls. It is used when the accuracy of the weight is of minor importance compared to getting the correct number of items. To move the product to the filler, different conveying systems are used. Piston pumps or gear pumps can transfer foods of varying viscosity at a steady rate. Diaphragm pumps are used for smaller quantities and less viscous products. Screw pumps or rotary pumps handle larger quantities of liquids, granules, and powders. For sensitive solid products, belts and vibrating surfaces are used. The systems used to transfer food into the containers depend on the nature and consistency of the product. Transfer can be done based on gravity, pressure, isobaric principles, vacuum, or a combination of these. Gravity transfer is used when the product flows easily, like low viscosity liquids. Pressure transfer can increase the flow rate and is good for viscous foods. Isobaric transfer is for products sensitive to pressure changes. Vacuum transfer involves sucking the product up to the filler. Combined systems may use pressure along with gravity assistance for economic efficiency. Vacuum filling is a clean, rapid, and economical way of filling liquids. It automatically avoids filling defective bottles that cannot hold a vacuum. There is little loss of product, it enables foam-free filling, and there is no need to wash or wipe the bottles before labeling. The principle of a bottle filling valve using vacuum is simple. A concentric tube in the filler is connected to a low-pressure system. This sucks the air out of the bottle, creating a vacuum that causes the liquid to flow in from the product tank to equalize the pressure. This slide illustrates the principle of vacuum filling and pressure spring level filling, showing the movement of air and product into the bottle. For granulates and powders, the flow of product from a chute is controlled by gates and other devices like augers. Another method for granules and powders involves using a pre-filling container that matches the exact volume needed. This container is fixed on a carousel. In the first step, it is filled completely. In the second step, any excess product is swept away and recycled. In the third step, the pre-measured product is emptied into the final package. The diagram shows the recycling tank, the valve, the sweeping action, and the final container. Finally, we see an image of a vacuum bottle filling machine with two nozzles, a common sight in dairies for efficient liquid filling. Thank you for joining this first class on packaging machines. We've laid the groundwork by exploring the different types of filling methods and the principles behind getting the product into the package. This foundation is essential as we move on to more specific machines and sealing techniques in the next class. Thank you. See you in the next class.